welcome in this video. We are going to study about local maxima and local minima. But I want to tell you, to understand this video, I will recommend you to watch my previous video on maxima and minima, because I have given the complete introduction of maxima and minima. So here we go. So our topic is local maxima and minima. In the exam, we will be given a question and we have to check the points where the function is locally maximum and where the function is locally minimum. Then we are having two options to check the local maxima and minima. First is called first derivative test and the second is second derivative test. So first of all, we will understand what is first derivative test. So to understand first derivative test, let's see some situations. You know, this graph is showing a trend that at this point the tangent is parallel to x-axis, that is f dash x equal to 0. And you know, whenever f dash x is equal to 0, that is called stationary point. It means on this graph, this point is stationary. And before this point, the function was increasing, and after this point, the function is decreasing. It means function, the derivative is changing its sign positive to negative at this point. So this is the point of local maxima, because this point is the highest point in its neighborhood. Now come to the second situation. In this situation, this is also a stationary point. Why? Because at this point the slope of the tangent is parallel to x-axis, that is f dash x equal to 0. So this is also a stationary point. You know, before this point the function was decreasing and after this point the function is increasing. It means the derivative changes its sign from negative to positive. This is called the point of local minimum. Now this is another situation in which though we have f dash x is equal to 0, that is we have a stationary point, but function is not changing its state. That is, before the stationary point the function was increasing and after the stationary point function is still increasing. So this type of point where the derivative is not changing its sign, so that is called point of inflection. So if we have understood these three situations, then it will be very easy to understand the steps of the first derivative test. So what are these steps? Step number 1, you have to find first derivative, that is dy upon dx. It is your first step. Now in second step, because we need to find the stationary point, and you know, at a stationary point there may be local maxima, local minima or point of inflection. So for these three situations we have to put the derivative equal to 0, and when we put the first derivative equal to 0, then from this equation we will get some roots. So I have given the name of the roots. These roots may be alpha, beta, gamma, 1, more than 1 or etc. Now the third step is we have to check the sign of the f dash x. Remember, we have to check the sign. We have to check the sign of f dash x. So for example, suppose at x is equal to alpha, that is the at first root. Suppose before alpha the sign of derivative is positive. Suppose x is equal to 1. So I can check at 0.9 or 0.5, or maybe I can take 0 according to the interval. So if before alpha the sign is positive and after alpha the sign is negative, whose sign? The sign of f dash x. So if sign is changing plus to minus, then it will be local maxima. And suppose there is a point beta where the derivative sign, that is sign of f dash x, is changing from minus to plus, that is minus to plus, then this point is called local minima. And suppose if at any point, for example gamma, the sign of the derivative is not changing, that is plus to plus or maybe minus to minus, then such point is called point of inflection. So this is the technique how to check local maxima minima with the help of first derivative test. Now for the second derivative test, come to see these steps. Here are the steps. 1 and 2 steps are same as it was in the first derivative test. That is, we need to find derivative f dash x, or we can say dy upon dx. And you know, for a stationary point, we have to put dy upon dx equal to 0 to get these roots alpha, beta, gamma. Because this test is the second derivative test, so we need to find second derivative, that is d2y dx2. Now in fourth step, we will check the sign of the second derivative. Remember, in first derivative we were looking the sign of first derivative. In second derivative test, we are checking the sign of second derivative. Now suppose at any point, maybe alpha, you know, if the sign of second derivative is negative, less than 0, then it will be a local maxima. On negative, it will be local maxima. And suppose at any point, maybe beta, if the sign of second derivative is positive, then it will be local minima. And if suppose at any point the second derivative is become 0, then we need to find third derivative. We need to find third derivative. And at the same point, if the third derivative is not 0, then this is the point of inflection. And their question arising, if it is still 0, then generally we cannot go above this test. We will tell that this test is failed to check, to decide the nature, then it will be easy to check from the first derivative test. Actually, these two tests are depending upon the situation. In some question, it is difficult to find the second derivative. So in that situation, we can check the sign of first derivative and comment about the local maxima and minima. But whenever we can easily find the second derivative, so we can use second derivative test. Generally, it will not written in the question, just written that find the local maxima and minima. Then you have a choice that both of the tests you can use. Now for some question, keep watching. See, we have a question in which find the points of local maxima and local minima of the function. So function is given to us. Now I will do this question with both the techniques, that is first derivative test and the second derivative test. Just just try to making the concept clear to you. So step 1, we need to find derivative, and here we have a differentiation of this function. So this is the function. Now I have taken 3 as a common, and this is a quadratic polynomial, and this is the factorization of the quadratic polynomial, you know, by middle term splitting. So this is a derivative f dash x. Now you know, to find stationary points, we need to put f dash x equal to 0. So we will put this expression to 0. So obviously we will have x is equal to 1 and x is equal to 3. So these are your stationary points where local maxima, minima or point of inflection may be occur. Now suppose I want to check at x is equal to 1 whether this is the point of local maxima or local minima. So I need to find the sign of f dash x. I need to find the sign of f dash x. So this is the best expression for f dash x to check the sign. Suppose at 1 to f dash x is equal to 0. Before 1. So before 1 I can take easily 0 because before 1 there is a value 0. So I have finding the value of derivative at 0. So see the sign, this is positive. It means the sign of f dash x before 1 is positive. Now after 1 I cannot take 3, but 1 and 3 there is a point 2. I can take this value. So I need to find the value of the derivative at 2, and here I have got which is negative. It means after 1 the sign of the derivative is negative. So see, the sign is changing from plus to minus. So this is the point of local maxima. So I can write at x is equal to 1 local maxima. So this is local maxima. Now come to the point 3. So I need to check the sign of derivative before 3. So you know before 3 there is a point 2, and I have already checked the sign which is negative. Then after 3 I can take a point 4, and at x is equal to 4 the sign of the derivative you see positive. So now you know whenever derivative is passing through point 3, so sign is changing minus to plus. So it means at x is equal to 3 local minima. This is called local minima. So this was the first derivative test. Now how can we do this question with the second derivative test? Just you know, to differentiate what I am doing, in this question I am writing down f dash x, and in this question I am writing down dy upon dx. It has no difference, but just to make a difference between first derivative and the second derivative. It is just a matter of narration, just a matter of expression only. So y has given to us, so we will differentiate this dy upon dx, and here we have the first derivative. You know 4 stationary points, we will put dy upon dx is equal to 0, and as in previous case we have got x is equal to 1 and x is equal to 3. But in second order derivative test we need to find d2y dx2. So which I have got from this formula 3 2 6x minus 12. This is our second derivative. Now I need to check the sign on this of second order derivative, on second order value at x is equal to 1. So at x is equal to 1, I have put the value x is equal to 1 in this expression. So 6 into 1 minus 12, I have got minus 6, which is negative. And in second order derivative test, if second order at any point is negative, then that is the point of local maxima. So it means at x is equal to 1, there is local maxima. Now similarly at x is equal to 3, so I am putting x is equal to 3 in the second derivative. So 6 3 is 18 minus 12. Now I am getting 6, which is positive. And at this case at x is equal to 3 there is local minima. Now we have done this question from both the method. Now one thing is left to tell you, that if we need to find the local maximum value or local minimum value. So suppose I know that at x is equal to 1 there is local maxima. So to find local maximum value I have to put x is equal to 1 in the function. So if I am putting x is equal to 1 in the function, so I will get 1 minus 6 plus 9 plus 15, 19. So this way, so this is the local maximum value. And if I want to know what is the local minimum value, then I have put x is equal to 3 again in the function, then I will get the local minimum value. So for more question I will make another video. So keep watching my videos. Thank you very much.